Welcome to the lecture series on soft computing in computer science. In this lecture, we are going to see about some advanced as well as very latest and popular widely used neural network architecture, and it is called by the name deep neural network. So, if you could see the title of this slide, it is shallow neural network versus deep neural network. So, you could wonder, so far we have not seen a title called shallow neural network, then what it is. So, why this shallow neural network is, in order to have a better understanding about the deep neural network, we are giving a title called shallow neural network. Why this shallow neural network? Because the word deep in deep neural network corresponds to number of layers. So, if when more number of layers are there, then we can go with deep neural network, otherwise we can go with shallow neural network. So, the shallow in terms of the neural network concept is given by means of the number of layers. When you see the picture, you can very well differentiate between the shallow as well as the deep. So, we have seen a backpropagation neural network which consists of input layer, hidden layer and output layer. So, this neural network is treated as a shallow neural network. But here one question arises, in a backpropagation neural network we can increase enormous amount of hidden layers, no restriction in the number of hidden layers. So, if keep on increasing the number of hidden layers, then it can have n number of layers in the network. So, we may call them as a deep neural network, but it is not the case. I will explain you in the due course why this shallow neural network is having this name and why the deep neural network is having the this name like shallow and deep. What is the fundamental difference between shallow and deep? If you look at this picture here, this is the very popular model from the year 1980s and it is called by the name backpropagation neural network. You have input layer, you have hidden layer and you have output layer. If you take each neuron in the layer, both in the hidden as well as the output layer, it is two tasks. What are the two tasks? One is summation, another one is activation. So, when you recall our previous lecture of the idea that introduces the neural network, see the neural network is doing two tasks, one is the summation, that is accumulation of all the inputs, again one is ejection of the output. So, this neuron is doing this task and collectively all the neurons are doing the same task, and whenever you increase the number of layers, all the neurons are also intended to these two tasks. So, on the whole the neural network is meant for doing these two tasks collectively, and based on that it will do the weight updation as well as error calculation process, and it is going back and forth in order to establish or in order to identify the relationship between the input and output. So, that is the major idea behind the learning principle of the in general neural network model. But with respect to layer, it is given shallow. Even though you can increase the number of hidden layers, we may not call them as a deep neural network, because each neuron in the layer is intended for a specific task of doing the summation as well as the production of the output. But when you take the deep neural network, here how many layers are there? One hidden layer, two hidden layer, three hidden layers. So, we have three hidden layers in it. Architecturally we can see three hidden layer in it, but in each hidden layer the set of neurons are doing different kind of task. Say for example, this layer is meant for identification of edges, and this set of hidden layer is meant for doing identifying the combination of edges, and this set of hidden layer is meant for doing the identification of the features. So, this is the difference and wide functional difference between the shallow as well as the deep neural network. Both the case we can have enormous amount of layers, but whatever may be the number of layers in a shallow neural network, all the layers are doing only the predefined, it is not predefined, it is the same kind of task almost all the neurons, but it is not the case with the deep neural network. Each layer is responsible for a different kind of task. Almost the objective is to identify or doing the task called pattern recognition. It is already said to in the introduction itself while discussing about soft computing. Neural network is meant for doing the pattern recognition task, fuzzy logic is meant for doing the decision making task, and evolutionary algorithm is meant for doing the optimization task. So, of course, both these kind of neural network, shallow neural network as well as a deep neural network is going to do the same task of pattern recognition, but how functionally it gets differentiated is the major question here. According to the functional difference of each and every layer, we call this neural network as deep neural network and this neural network as a shallow neural network. So, the word shallow is a opposite to the word deep. So, this deep neural network is an advanced form of neural network, and most of the modern researchers are using this latest neural network model for variety of the research as well as engineering problems. Coming to the general idea of doing the pattern recognition. When you want to do a pattern recognition, so what is a pattern? Given an input image, we have to say what it is. When I give this input image, we may easily say that what is that image? This image belongs to a cat or a small cat, that is kitten, but we need ANN model to say what this image is all about. So, it may say any one of the answer, kitten, puppy or none maybe, and it will give some probabilistic value. Kitten it might be 0.9, puppy it may be 0.5, none it may be 0.5, like that maybe, so 0.05, 0.05 like that maybe, put together one, right. So, what is pattern recognition? Given an input image, you should say what it is. When you apply shallow neural network, so what it is doing is, it is expecting the important features from the input data, because originally the shallow neural network model or the widely used feed forward neural network trained using backpropagation algorithm is widely used for structured data, that is the data in the form of table. We have seen lot of case studies and applications right from iris data classification, intrusion detection, diabetes prediction, body fat forecasting, then breast cancer detection. So, all those cases we have seen some example data, and if you could see that the data are structured in form, that means it contains some rows and columns. In rows we have samples, in columns we have input features. So, the structured data. So, whenever this image data or something like unstructured data is given, the unstructured data has been converted into a structured form, that means the important features are identified and it is recorded in a tabular form. So, the tabular form data is fed to the neural network model, and that neural model is said to do the task of classification. So, this is what all about shallow neural network task, but when you come to deep neural network, it has both the functionality inbuilt in it, feature extraction along with the classification. So, it is a 2-in-1 model, whereas your shallow neural network is doing only the task of classification, but when you apply deep neural network and it is accepting any unstructured data, image, video, speech, signal, waveform. So, any text, any unstructured data it is accepting it, and it does the task of feature extraction followed by classification. So, each and every layer in the deep neural network is intended to do a specific task that interested to find out the important features, making the data into a structured one, so that the final stage will do a classification in order to understand what the given input is, whether it is kitten or puppy or nothing else according to the input data. So, this is the fundamental difference between the shallow neural network as well as the deep neural network with respect to the pattern recognition task. Yet another example of illustrating how the deep neural network is working. Let me take another example of face recognition, right. See the group image. Imagine I want to design a automatic attendance entry system. A teacher is taking a class, the students are listening to the class, a camera is behind the teacher, maybe above the blackboard, and it takes the picture. It means it takes the picture and it is monitoring the presence and as well as absence of all the students. So, in that case the neural network will have to identify each and every face. So, what is the student name and roll number, what is the student name and roll number, what is the student name and roll number, like that, and it mark attendance. So, it means that it is a kind of face recognition system, that face recognition system among the groups, it is a kind of things, it is a kind of things. When you subject this kind of data to a model, see the neural networks, this is one big neural network, this is one big neural network and it is treated as a hidden layer, and this is another neural network that is treated as another hidden layer, and finally the output layer doing the task of identification of the faces. So, first what it is do? It is identifying the patterns of local interest, what pattern we are exactly interested to locate. So, that is the first input layers task according to this architecture. And next what it is doing? Identification of the facial features, that is the first hidden layer task. All the nodes in that hidden layer are doing collectively this feature extraction, this face feature extraction task. Now, the third one, that is the hidden layer 2, is doing the task of facial identification. Finally, the classification of the faces according to the name of the persons. Yet another picture showing the detailed understanding of what a deep neural network is all about, right. Now, what is the key concepts of deep neural network? So, deep neural networks are distinguished from single hidden layer neural network, that is shallow neural network, by their depth. So, what is meant by depth? It is nothing but the number of layers. So, that is, if an input data must pass through many layers treated as a multi-step process for pattern recognition, each layer of nodes trains on a distinct set of features based on the previous layers output. So, that is the key concept behind the deep neural network. So, how this deep neural network is working? This deep neural network finds complex relationship in the data. So, what the first hidden layer might be doing? It is trying to find some simple functions like identification of edges in the image, or identification of the corners, or identification of the templates. So, those kind of very basic preliminary tasks. As we go deeper into the network, these simple functions combine together, all the simple functions in each and every layers are combined together to form a more complex function like identification of the face. So, this is what the deep neural network is doing. So, let me come to take the first example, face recognition. So, we are given with input image. So, what is the first task? Identification of the edges. What is the second task? Identification of the face parts. What is the third task? Identification of the face. What is the fourth task? Whose face it is? That is categorizing the face. Likewise, when you give any audio as an input, first what it does? It will do the extraction of low level sound features like the triple S as well as double B, identification of the phonemes, identification of the words, as well as the final identification of the sentence. So, each and every, this is maybe the group of layer 1 and this may be group of layer 2, layer 3 and the final layer 4. So, this is what the deep neural network is all about. So, when you provide with any complex unstructured data, your duty is to simplify the task of identification of the image by assigning primitive task to the fundamental layer, to the next level of task, to a next level of task, to a next level of task, to the higher level of task, to the final intended task across various layers. So, collectively the layers are working together in order to produce the final output. So, this is the basic fundamental principles behind the deep neural networks. So, what is deep learning? The learning principles that is followed in a deep neural network is called deep learning. So, nowadays this word is very popular because of the emergence of artificial intelligence in all the nook and corner. See, this deep learning is a subset of machine learning, because it is also trying to make a machine to understand the data, to understand the behavior as well as characteristics of the data, and according to the data it tries to produce some results. So, it is one of the main component in the field of artificial neural networks, right. Next, when you coming to the various techniques in deep learning, we may have 3 different techniques like multi-layer neural networks, convolutional neural networks, and recurrent neural networks. So, 3 models are available, and each algorithms that are followed in each of the model will be looking at a idea of deep learning, where the inputs are analog, meaning they are not few quantities in a tabular format, but instead of images of pixel data, documents of text data, and files of audio video data. So, that you should keep in mind. So, whatever the application that we have seen in the previous sessions, all are utilizing the data that is of structured in nature, that carries only values, that may be a numerical value or categorical value. But coming to deep learning, the idea is training deep the neural network, that is many layered neural network with respect to various tasks. Maybe the data are images, text, audio and video. So, that is the idea behind deep learning. In this category, the multi-layer perceptron, that is what we are discussed so far. You may have many perceptron layers, but all perceptron layers are doing the 2 tasks like summation and activity. So, that is not deep learning. Then what is deep learning? Each layer is responsible for an intended task of its idea. So, that is called deep learning. Let me come to the first model that is widely used in many of the field nowadays, that is called convolutional neural network. Convolutional neural network, CNN shortly, or otherwise called as ConvNet, is a class of deep feed forward artificial neural network most commonly applied to analyzing visual imagery. This network is a great example of variation of multi-layer perceptron for processing and classification. It is a deep learning algorithm in which it takes input as image and puts weights and bias effectively to its objects, and finally able to differentiate images from each other. There are 3 types of layer in this convolutional neural network. We may have enormous amount of layers, but those layers can be categorized into 3 categories. One is convolutional layer, and another one is pooling layer, and the last one is fully connected layer. So, these are the 3 layers that are fundamentally available in the convolutional neural network model in order to conduct the process of pattern recognition. So, this is the basic architecture with respect to convolutional neural network. See, the input image is given, the input image is fed with so many convolutional operation, followed by another operation called pooling operation, and alternatively convolution as well as pooling has been conducted across many layers. Layer 1, so layer 1, layer 2, layer 3, layer 4, layer 1, layer 2, layer 3, layer 4. So, likewise, and finally you have fully connected layer. That fully connected layer, that you may treat that as a backpropagation neural network which is doing the task of. I already said that in the previous examples, as well as the code, as well as the demo, as well as the applications. So, the neural network will give you a probabilistic values according to the input, where which only we have obtained threshold. I think if you remember my previous lecture, in all the codes I try to select a threshold of 0.5 over and above. We need to categorize the data as either 0 or 1, accordingly the classification task has been carried out. So, likewise here also when you input an image, the type of the image may be a dog, may be a cat, may be a deer, may be a lion. So, according to the probability value 0.1% it is dog, 0.4% it may be cat, and 0.94% it may be a deer, and 0.2% it may be a lion. So, what is the final outcome? Which is having the maximum percentage, that is the final outcome of the pair. And what is the intended task performed by the convolution? Identification of the feature map. In pooling, pooled feature maps. So, feature maps, pooled feature maps, like that. So, that is the task performed in the fundamental any architectures of CNN model. So, what is the basic architecture is almost saying each inputs image passes through a series of convolutional layers with the filters, that is kernels, pooling layers, fully connected layers, it is shortly called as FC, and apply softmax function, that is the final layer function, like a kind of activation function to classify an object with probabilistic values between 0 and 1. So, that you should remember. The convolution along with the pooling layer act as feature extractors. So, if you could see this architecture, so this layer up to this layer, that is convolution pooling, convolution pooling, convolution pooling. So, those set of layers are meant for feature extraction, and the last set of layers, that is called fully connected layer, are meant for classification. CNN basic architecture, if you could see that convolution operation, non-linearity, that means usage of an activation functions, that is very well addressing the non-linearity present in the data, and pooling, or it is otherwise called by the name subsampling, and finally classification. These are the 4 major operations present in the convenient. What is convolution operation in general? So, when you are provided with an image of size 5 cross 5, imagine what is this each value 1, 0, this 2 represent, this is the pixel value, right. If you are doing the convolution operation, you have to take any kernel, it is another matrix, but we will be having some values, there are some standard kernels are available, but size you should define. So, here the size taken is a 3 cross 3 kernel. So, given a 5 cross 5 image, a 3 cross 3 kernel has been chosen, and we need to perform a convolution operation between them. So, what is this convolution operation? You have to place this kernel as a window here, see window here first, after that second it has to be placed here, after that third it has to be placed here, then fourth. Likewise, it has been like a sliding window, it has been moved from one thing to another thing. So, what is this convolution operation? It is, see, look at this, 1 multiplied by 1 plus 0 multiplied by 1 plus 2 multiplied by 0, this is the first one. Second, 0 multiplied by 2, 2 multiplied by 1 and 1 multiplied by 1, this is the second one, and 1 multiplied by 7, 0 multiplied by 0 and 1 multiplied by 2. So, this is likewise when you move the over building, it is the multiplication is carried out, and this product of sum has been calculated and the value comes 13, and this 13 is made available here. Now, this is the input for the first convolutional layer, and this is the output. So, according to the kernel size, what do you infer from this? According to the kernel size, the image size is reduced to the kernel size of the convolution operation, right. So, this is the final image. So, this image has been converted like into this reduced form, a 5 cross 5 is changed into a 3 cross 3 image. So, that is the final result of a convolution operation, whatever may be the kind of image you are giving it. ReLU. In a neural network, we are already familiar with the role of activation function. The activation function is responsible for transforming the summed weighted input, right. So, we have performing the summation net input calculation, right, summed weighted input from a node, it get to be activated in order to get the final output. So, that is the in general the task of a activation function. But when you coming to the ReLU operation, that is rectified linear unit operation. So, what it is actually? This rectified linear operation is often treated as a kind of convolutional operation that applies element wise activation function. For each and every element the activation is carried out. So, it is a piecewise linear function that will output the input directly. If it is positive, otherwise it will output 0. Let me explain the next slide how it is. So, when it reads the input and if it is positive, then it will leave. In case if that input is negative, then convert the negative value into a 0. So, that is what it is doing. It is a piecewise linear function. So, it is applied per pixel, each and every pixel it is applying. So, if say for example, if you are having an image, the image is of, so it is a 3 cross 3 image, here the pixel is 1, here the pixel is -1, here the pixel is 0, here the pixel is -2, -3, +1, 5, 6, -8. So, wherever the minus values are there, it changes the minus value into 0. So, that is the ReLU operation. So, it is applied per pixel and replaces all negative pixel values in the feature map by 0. So, this leaves the size of the volume. So, that means if it is a 3 cross 3 image, same 3 cross 3 image is retained, but the values it changes. So, first in convolution operation what is happened? A 5 cross 5 image is converted into a 3 cross 3 image, right. But in case of ReLU, the operation is changed the values. See, look at the image here. So, it is I think 4 cross 4 matrix. Where are the values that are having minus value? -10, -110 and -15, -10. Look at it, the -10 is changed to 0, this -110 is changed to 0, this 15 is changed to 0, this 10 is also changed to 0 by applying the transfer function, or otherwise called by the name activation function. What is this activation function? Rectified linear unit. So, this is the way in which you are doing the ReLU operation, is one of the major step of a convolutional neural network. So, the input image is taken, the input image is applied to a convolution layer. So, input image is reduced to a particular size that depends on the kernel size, and over that we are applying the rectifier idea, and that will choose the maximum value. Here the x comma 0, max of x comma 0. Suppose if the pixel value is 5, then what is the value is written? 5 is written. Suppose if the pixel value is -3, what is written? Max of -3, 0 is written. So, this is what the ReLU operation. Yes, I hope until now you understand the two major operation of the convolutional neural network. One is convolutional operation followed by the ReLU operation. Convolutional operation will tries to reduce the image size according to the kernel size that has been chosen, and ReLU operation will work per pixel and tries to change the pixel value according to the nature of the value. If it is positive, left as it is; if it is negative, convert it to the 0. With this, I close this presentation, and the continuous idea about the convolutional neural network, followed by one more neural network is there, deep neural network is there, that is recurrent neural network, that will be covered in the next session.